Hello everyone, I hope you are all doing great. From today we are going to start our new series of circuit schematic and PCB layout designing. And in this series I will use DipTrace software for circuit schematic and PCB layout design, and we will try to learn how to use DipTrace software and how to design a circuit schematic PCB. But before designing a schematic or PCB, we need to design the components footprints. First we try to find all the components in the built-in libraries of the DipTrace or any other software, but maybe some components sometime we do not find a specific component in a library. So in that case we need to design a custom component footprint and the schematic symbol. So let's start. Why I am going to start with the DipTrace software? Because DipTrace software is very easy to use software. It is a few MBs. Everyone can easily download and install it. You can you just go to the DipTrace website and go to downloads, and you see it is a just 220 MBs software. So there are the latest version. It is a paid software, but they also give us a free version, but it is a limited edition of this software. In the free version you can design the schematic up to 300 pins. It means, for example, if you use an IC of 20 pins, so 20 pins will be counted out of 300. So the number of pins, the number of components may vary, depends on the number of pins of each component. So basically you can design a schematic up to 300 pins, and in the free version you can design only the 2-layer PCB. So you can download it for the beginners, and just for learning the DipTrace software you can download this free version from here and can install it. I have installed it. When you will see this menu, in this here you can see, if you directly want to start from the schematic, you just need to click here and the schematic will be open. This is the PCB layout. If you want to open the PCB window directly, these are the component editor, and this is pattern editor. Component editor means if you want to design your custom component schematic symbol, and pattern editor is basically the for designing the custom component footprint, PCB footprint. So this is the schematic window. It will be just here. This is the schematic, and all these components are this is the basically the built-in library of the components in DipTrace. You can find any component here. A lot of components are available here, you can see. So for example, if you design a PCB for a specific if you want to use a specific component which is not available here, then you will have to design your own component for schematic symbol and PCB footprint. This is a PCB footprint and this is a schematic symbol. For example, this is a I pick a component, I can pick a connector. So in the schematic you will see the schematic symbol of this, like this is the schematic symbol, and this one is the PCB footprint. So on the PCB this component will appear in this shape. Okay, so this is the PCB you can start it from here. If you directly want to design the PCB without schematic, so you can open it from here. This is the PCB menu or the page. Here all the components are available same. So you see component, I think we used the same one in the schematic. So here you see this is the PCB footprint. So if we want to use a component which is not available here in this built-in library of the DipTrace, then what we will do, we will have to design our own custom footprint and schematic symbol for the component. In this video we will going to start from the footprint design, and just for the practice I want to use ESP32 microcontroller, and we will design the footprint of ESP32. So for the component there are different suppliers, and I normally pick component from DigiKey. So we are going to pick ESP32 WROOM microcontroller, and just for the PCB footprint we open this component. All the details are given here, but we need to open its data sheet. In the data sheet we will find its mechanical dimensions and the footprint layout. This is the ESP chip, this is with antenna and this is without antenna. All the details are given in the electrical and mechanical details of the chip is given in the data sheet, but at the moment we need its schematic symbol details and the PCB layout footprint details. This is the pin numbers and how the pin numbers are how the pins are numbered. Here we will use this picture, so we need to remember this page 10, and then now we will go to the footprint page. At the bottom here you can see its physical dimensions of the component. Here we are going to use the ESP which is with the antenna, so this is its footprint details. We need to zoom it. So here first of all we will try to learn how to read these numbers, and with the help of these readings we will design this footprint in PCB in a DipTrace. So here if we see the overall dimension of this component, this ESP, its width is 18 mm, the unit is given here millimeter, and its overall length is around 25.5 mm. So we will start it. Let's go to component editor. Okay, when you will open it, all this is a built-in library of the DipTrace, but you will go here to the user patterns. You can add new library here, you just add it here, name it and save it. But I already have this, so I will add the component to this library. So here we will add new pattern, yes. Name of the component, so we will go here, and the name of the component is basically this, the manufacturer part number, this is its name. We will go to put it here. Reference designator, it's U, IC, its value. We will go here and we will see its description. The description is basically its value. Description, we will put it here. Who is its manufacturer? Manufacturer is this one. Its data sheet. Copy this link, place it here. Okay, now this point is basically the 0 point, so we will start from here. We will place our pads from this point. So here you can see these are the pads. So first we need to select this one, just click on it and then click here. Okay, we see the SMD components. If basically it is saved, it appears the SMD components, but basically the last component I designed in this here was the SMD component, so therefore the last setting is saved here and directly the SMD pad came. So if your last settings are were for the through hole component, then the through hole pad will come here. You can change this is the position, XY position here, but you will go there, click this, and you can change its length and width, its shape as well, surface mount or through hole. So we need surface mount, we need rectangle shape, we will set its length and width. So we will see from the data sheet, we will check from the data sheet what is its length and its width. So here we can see the width of the length of this pad is basically 0.9 mm. 38 means there are 38 pads from 1 to 38, all are of same dimension, so therefore 38 is mentioned here. So 0.9 this one, and its width is 1.5 mm. So basically it is 0.9, width is 1.5. So you see, okay. Now the first pad you placed here, it will be automatically numbered 1. So here if we see, our first pad number 1 is at the top. So first we need to place all the 14 pads here, and it's 1, 2, 3, 4, Okay, so the 14th one should be, the position of it should be on the 0, detect 0. Okay, it is on 0. Now go to the data sheet again and see what is the pitch, the distance between two pads. So here we will find this reading, this dimensions. So here we can find it, the distance between two pads is 1.27 mm, or we can say the pitch of the pads is 1.27 mm. So first of all, just go here and change the grid size. The grid size, basically this is the grid and the grid size is now 0.1, so we need to change it to 1.27. Okay, so basically this is 0 0 position, this is 1 point, it should be 1.27. Okay, now you see it should be 2.54. How 2.54? You will just need to add it. 0 plus 1.27 plus 1.27, 2.54 plus 1.27, it should be 3.81. .81. 5.08 should be the next reading, you can calculate it. Okay, plus 1.27 plus 1.27, 6.35, 6.35, .62 should be 0, 7.62, .16, .16, plus 1.27, 1143, 1143, 12.7, 12.7, 1.27, 1397, plus 1.27, 1524, 1524, 16.15, 16.51, sorry. Okay, so this row is completed from 1 to 40. This is pad 1, 2, 3, and this is pad 40. So Control S. Again we need to place our next pads here, 14 to 24, 10 pads here. Just click on the component. If you want to rotate the pad, you just click on the component and then press space button on the keyboard. I am placing them randomly right now. We will set their dimensions. Okay. So first of all, before setting the dimension of this row, we need to complete the right side column, this one column, from 25 to 38. So here it should be on 0, 0, and we will see what is the distance from this pad to this pad. So here again we go to the data sheet and we will see what is the distance between this pad to this pad. So here from the mid of this pin 14, this dimension here, it goes to the mid of this pad 25. So it is 17.5 mm, right? From the mid of this pad 14 to the mid of this pad 25, it is 17.5. So we will set it at 17.5. okay, so this should be the pad 25, right? You see 25, 28. Now basically our grid is at the grid size is 1.27, so we will just place it on the on each row of the grid at the distance of 1 point. It will also help you here. You see, when it aligns with the other pads, it will help you. here you see. Now you can see the dimension. It is on the x location is the x location is 17.5 and the y location is 0. It should be 1.27. 1.27, it should be 5.5, 2.50, 3.81. And in this same case we can complete .16 is okay. What is its number? Its number is 33. So we need 5 more. Right, so these two columns are completed. So we need to verify the distance here. Here this is the dimension icon. We need the horizontal from the mid to its mid. It is 17.5. And we can also verify vertical. You can see 1.27. Okay, so the two columns are completed. Now we need to set the dimension of this one. So okay, just for the easy dimensions we need to move it a bit above. It is on, what is its y location? It should be 2. Control C. Should be on 1.27. Okay, now open data sheet and let's see the data sheet. In the data sheet we need to find the distance between the pad 14 to this pad 15, its y location and its x location. So for its x location we need to find the distance between this pad 14 to this pad 15. So here we can see from the mid of this pad to this pad is 17.5, but here from this point from the mid of this pad 15 to this line, but if you see this line is not at the mid of this pad 14, there is some difference. So we need to find this difference. So basically if we check this line, we see from this to this dimension is 18, and from the mid of this pad to this pad it is 17.5. so basically there is a difference of 0.5 mm here and here, but it is on the both side So 0.5 mm is divided into two parts, 0.25 mm difference here and 2.5 mm difference here, you see. So it is on position 0 here, it is on position 0, the x position is 0, and this line is a bit shifted towards the right side, so it is basically 0.25 mm shifted. So we will take the dimension of this pad from this line, which is minus 0.25 in x direction, minus 0.5. So from 0 to here, if we shift it here, we will see, if we count it from the 0 position, then this is basically 3.285, but it is from this line, this dimension is given here, from the mid of this pad 15 to this line is 3.285, but basically it is 0.25 mm shifted towards right, not in the mid. It is not aligned, this line is not aligned with the midpoint of this pad. So 3.285 mm minus this 0.25, then we will get our dimensions. So basically 3.285 minus 0.25, it will be 3.035. So basically its x location should be this one here. Now we need to find its x location, its y location. So for its y location, from mid of this line here, we can see it is also 0.5 mm from the corner of, or the from the corner of this pad here to this line, it is basically 0.5, and from this line to the mid of this is basically 1.5. This is 1.5 and this is 0.5. So 0.5 plus 1.5, so it is 2 from the mid of this pad 14 to the corner of this, the bottom corner of this pad 15, it is basically 2 mm. It is 2 mm, so it should be y 0, its position is 1.27, and the distance from this point to this corner should be 2 mm. So we can find it from the mid of this point to the corner of this pad. It should be 2 mm. So we need to 1.29 is extra, so in 1.2, if it is 0, it's 2, it will be 0 0.2, oh no, 0.02, 2 mm. Okay, so now we need to the distance between this and this pad is the same as between these two, so it is 1.27. so this position plus 1.27, 4.305. We will set the dimension of all these. So here we set the dimensions of this row. Now we can measure the horizontal, here 3.8, so now the numbering is completed and the dimensions are completed. We just need to verify this thing, this line. We need to draw this line and then we will verify the dimensions with this one, right? So basically from the mid of this to this point is 3.285, but the line is starting from here and the width of this pad is basically 0.9, so the half will be 0.45 mm, right? So 3.285 minus 0.45, 3.285 minus 0.45, 2 point this one, okay. So we will place a line here. we will place line from here. Just draw it. We will see the dimension of this one, the x dimension. It is 3.035 minus 0.45, it's 2.585. Okay, so its starting point, the x, is this one, and its length should be, okay, no problem, we set it here. Starting position is here, and it should not be at 0, because the distance from the mid of this line, from the mid of this pad to this line is 1.5, this one, so it should be, it is 1.27 positive minus 1.5, it is minus 0.23, minus 0.23. Yes, here, and this is basically 0.9, it was 0.9, so we can reduce it a bit more so that it can start, sorry, not this one, this one. Yeah, we can see, just it should start from the edge of this. Here, now it is okay. Now we calculated this length, and we saw that from this corner to this pad, from this corner, from the mid of this pad to this line, its length is 3.27285, but basically it is from here, this point, so it should be the distance between the mid and this point was 0.25, right? So the end point, this x, should be minus 0.25. Here it should be here, right? And again we need another line. It should be started from here, and okay, its location, the location of this pad is basically 1.27, and this area, this part is 0.45 minus 0.45, so it should be 0.82. So the start point of this line is this, x location is minus 0.5 and y location is this. The end point of this should not be 0, this should be this, and the x location should be same. Sorry. 0.82, okay, and the starting point of this one is this. Starting from here, x position should be same. Here, but you see again it is according to the calculations, it is overlapping with the pad, so we need to change this thing. The end point should be 0. Not this one but this one. Same thing, we can do it 7, 5, 7. Yes, it is okay now. So we see again, we can copy it, we can place it here, we can check its y location. We will copy its y location. Its y location is 0.23, so we will set it the same, 0.23. it is a bit there. We need to change this thing. Same, Ctrl C. We will copy this one. We set the other part. Just 1 second, let me place this one. The distance from this point to this point should be 18, right? So the midpoint of this line, the mid of this pad is 17.5 plus 0.17.5 plus 0.25, 17.75, 17.75, 17.75, right? It is here, but this line should be a bit, it should be here, but it should, the x, wow, this location should be same. Now this is okay. Now we will see what is the distance from this point to this point. It should be, it should be 18 mm, right? It is 17.5. Delete this one, delete this thing, delete this one. We just need to verify the dimensions. Go here, from this point to the mid of this point is this, you can see. From this point to the mid of this point, it should be same. You can see 8.285, 8.285, same as these ones. Okay, so now we can see from the mid of this point, this pad, to the antenna part is basically 7.49, right? We can say it is 7.5. So here we again need a line. Here we can see it is a box, and from this point to this point it is basically 6.19. So what is the length of this line? It should be, it is 7. Let's see, I say it is 7.5 minus 6.2, right? Okay, so it is 1.3 mm. The length of this one is 1.3 mm. So again we need a line from this point here. Okay, vertical distance, the length of this should be 1.3. okay, 1.3 mm, right? It is here. We can see it is at location, the pad, the location of the pad is 17.78. okay, 17.78 plus 0.45, it should be 18.23. basically the mid, the location which is given here 17.78, it is the position of the midpoint of this. It is at the midpoint of this pad. The midpoint is located at this point 17.78, but the length of this pad is 0.9. So from the midpoint to this edge it should be 0.45, right? So we need to start this line from the edge of this. So the midpoint 17.78 plus 0.45, it is 18.23. So the starting point of this line is 18.23, right? This is here, and its length is 1.3. So add it here and you will get the same result. But its Y location, it is same as this one, like this one. So basically it is, we will have to see its X location. So it is basically at 0.25 minus 0.25. So its location also be the same, minus 0.25 minus 0.25. Yeah, just need to copy it. We will place it here. First of all, we need to set its 18.23, 18.23. Sorry, its X location is same, but again we will have to check this thing. It is 17.78, right, the midpoint, and we need to add 0.25 to it. So 17.78 plus 0.25, it is 18.03. Okay, so its X location is this one. It should be same. Sorry, we need these dimensions. .75, this one. Here it is 17.75 and its location is 17. X location 17.75 and it is 17.5. So here, and its starting point is basically, its starting point should be same as this one. Starting point is 18.23 and 18.53. 18.23 and 19.53. Okay, yes, that's good. Now we need to put a box here. It should start from here, this point. Okay, let's check its data sheet, and it is around 18 mm and its height is 6.1 6.2. Okay, just delete it, and this point to this, and this should be 6.19. Okay, no problem, we set it here. Okay, its length and width, it should be 18 and it should be 6.19. Okay, but it is a bit shifted, so it's this point. What is the end point of this line? This one. We need to copy it. Okay, now again go here, this position, its y should be Control V, it should be 0.25, I think so. 0.25, yes. We see it's completed. Pad 1, pad 38. Now just one thing left, this one. Basically this is a ground pad. It is in the schematic symbol we will point it as one pad. We will consider it a single pad. It is in a parts, but we will design a single pad for it. So we need its dimensions. It is 3.7 mm, 3.7 mm. Okay, and from this line it is located 7.5 mm here, and from this line it is located at 10.29, right? So first of all we need a pad. Again here, double click, go here, just uncheck this box, right? Same thing, 3.7, 3.7. If you do not uncheck the box I told you, this one, then if you change the dimensions, all the pads will be changed. So first of all uncheck this box and then make the setting. It's 3.7 at 3.7. now its location, we need to find it. So basically this, its location is 0.25, and from here to this midpoint it should be 7.5, right? So 0 plus 0.25, no sorry, 7.5 from this to this. So what should be its dimension position with respect to 0? So 0 is here and it is shifted a bit here, so it should be 7.25. position, and its X location should be 7.25. okay, yes, and its Y location, it is here. We will see it's 0.23, and its X position is 10.29. so with respect to ground, it should be 10.29 minus 0.23, so it should be 10.06. 10.06. 10.06. okay, so let's check if our dimensions are okay or not. From this line to the mid of this, it should be 7.5, and the Y location from this position to the mid, it should be 10.29. okay, all good to go. By the way, it's this pad number is 39. In this video, we learned how to design a footprint, PCB a footprint of a component in a DipTrace software, the PCB footprint. So we learned it. You can also add here, you see antenna is written here, so you can also add text here. You see it here, this text, just click here and write it. Antenna. Right, it is completed. Let me know if you have any question in this video, and in the next video we will design the schematic symbol of this component, and we will link this component with the schematic symbol, and then we will start our schematic. You can also add the 3D model here. 3D model, you can find it in the DG key, so if it is available or not, we will see it, the CAD file here, EDA model, go here, we will see if it is this model is currently not available. I think I have it, I have downloaded it from somewhere. We can go here, load model from here, and ESP32, I think I have it. This one, ESP32. You in DipTrace you need to find the step file, the 3D step file of the component, and then you can upload it. DipTrace only supports step file. Click here, open, and it will take a bit time because its 3D model is a bit heavy. Okay, so we have the 3D model here. You can set it, you can set the position its XY position here. From the data sheet, if we see, its overall length is 17.5, width is 17.5 and length is 25.5, and it is located in the mid. The 3D model is at the mid, so we need to shift it here and then on the top. So in the x direction we can move it like 17.5 divided by 2, 8 point here, and in the top side it is not exactly, but it is 25.5, so 25.5 divided by 2, so it's 12.75. It's y direction here, but you see, place it a bit high just to verify it. Sorry, the model crashed. I clicked on OK. Sorry, again it will take a bit time. So here the 3D model is okay, and we can also confirm the footprint we design, and it looks okay to me. So in this video we learned how to design the footprint of a component in a DipTrace software. The next video we will design the schematic symbol of this component ESP32, and we'll continue it. Thank you for now. See you in the next video. Thank you.